Hello, everyone. Welcome back. Here we go. Lesson. What chapter? Lesson is this? I can't even keep track of that. 323. All right. Lesson 323. We are going to start today with a warm up. I know it's kind of weird, but I want you to go to your warm up, and I want you to write down this warm up exponents. Look at that fun exponent thing. So we're going to go through this and see if you can figure out what the answer is. Actually, I guess we're not going to go through it. I want you to do this and I want you to pause the video, write this problem down, and then solve it. And then tomorrow we're going to go over it in class and see how you did. Okay, it's kind of crazy, and we'll see how the answers end up. Okay, so I'm going to just pause the video, do the warm up. When you're done, unpause it, and we'll come back to this. Okay, it'd be interesting to see what method you chose to use to solve this warm up. Okay, let's start today's lesson now. 323, how can I rewrite a product? Multiplying binomials and the distributive property. Okay, some interesting terminology there. In lesson 322, you made rectangles with algebra tiles and found the dimensions of the rectangles. Starting with the area of a rectangle as a sum, you wrote the area as a product. Today you will reverse the process, starting with the product and finding the area of a sum. Now, here is the first problem we're going to work on, problem 354. For each of the following rectangles, find the dimensions, length and width, and write the area as a product of the dimensions and as a sum of the tiles. Remember to combine like terms whenever possible. Okay, so I know we're not going to do this a lot, but I do need you to sketch this problem out. So if you could please sketch the rectangle out. Do not pull out the rulers. Do not try to be really fancy with it. Just sketch it, and then when you're done sketching it, you can pause the video, sketch it. When you're done, unpause it, and we'll work on this, okay? All right, so as you're doing this, probably the easiest way to do it is just take the sides and say, like at the bottom here, and say, okay, here we've got an x, here we've got another x. This value here, you just take the value there of that side, which is 1, 1, and 1. On the left-hand side, then, here we've got an x, and then a 1 and a 1. And so when I do this, what I'm doing is trying to find the area as a product. As a product, to get the area on the inside, I multiply the two sides. So it's on the outside. Well, on the left-hand side here, I've got x plus 2 times the quantity, and on the bottom, I've got 2x plus 3. So the quantity of 2x x plus 2 times the quantity of 2x plus 3. And that is equal to the area as a sum. So then at this point then, I add up all these individual parts. And you see that I've got 2x squared. And I've got 7x's, so plus 7x, plus 6. So therefore, the quantity of x plus 2 times the quantity of 2x plus 3 is equal to the quantity of 2x squared plus 7x plus 6. Cool? And this is the area as a product, and this is the area as a sum. Okay? All right, so now can you please go ahead and do it with B? So pause the video, sketch it, actually find the area as a product and as a sum, and then unpause it, and we will compare your answers. And again, for those of you who are not pausing and are just writing things down, please understand you're going to lose a lot of valuable practice if you do that. So please don't do that. I know it's not exciting, but please always try. Try the problems. Pausing, doing this is really the most powerful thing we can do here, okay? All right, here we go. You should have sketched it. I know it was kind of a pain. I know it was a pain to sketch, okay? But as you sketch this, hopefully you realize this was y. This was x, 1, 1. And over here, this is x, 1, 2, 3, 4. That tells me my answer. So I've got x plus 4 times y plus x plus 2. Now, commutative property does tell me that if I'm multiplying two values, I don't have to have them in this order. So I could have switched these two around so they were separate. Or a different order, that doesn't matter. I really don't care about the order in that case, as long as you've got all the parts to this together. And this is the area as a product. Now let's do the area as a sum. So area as a sum, I've got xy plus this right here would be an x squared because this right here is x all the way this way and x all the way this way, so x squared. Plus 1, 2, 3, 4 y's. Plus 1, 2, 3, 4, 5, 6 x's. Plus 8 tiles. And so this is my answer. Isn't that crazy? Crazy long there. Okay. Did you get it right? Hopefully. Now, we are going to do one other problem. We're going to start the other problem, and we're just going to do one of them. So here is problem 355. Your teacher will assign your team some of the expressions below. There's several of them, but we'll talk about them in class. Use your algebra tiles. Now, if you go to your book, which you're actually going to need to go to your book tomorrow. I think we'll just do this one together here. Use your algebra tiles and CPM to build rectangles with the given dimensions. Sketch each rectangle on your paper, label its dimensions, and write an equivalent statements for its area as a product and as a sum. Be prepared to share your solutions with the class. So I've got the quantity of x plus 3 times the quantity of 2x plus 1. This is actually kind of a challenging thing to do. We are going to be doing a series of these tomorrow in class, but I wanted to kind of walk you through the first one so you could see how we do it. Okay? So we've got the quantity of x plus 3 times 2x plus 1. X plus 3, I got to remember this because, So we're going to go to my algebra tiles, and it was x plus 3 times 2x plus 1. Now, what I want you to do is I want you to kind of picture the process we just did on the first problem and picture it in reverse. So think of, x plus 3 and then 2x plus 1. Now, when we do that, think about what we need. So right here, if I've got this section here of my rectangle and it's x here and 2x is here. Okay, now first of all, that probably means I'm going to have to spread this out a little bit. So x and 2x, what would fill that gap? Well, an x squared, wouldn't that? X squared, there's x right there. Oh, but I need 2 x's. So I'm going to go 2 x's. So that puts this right here as 2x. This puts it at x. Now I need plus 1. So how do I do a plus 1 if this part here is 1 and this part here is x? It would be filled in with an x. So plus 1. Then, over here I've got plus 3. So, okay, plus 3. I put it sideways. Okay, kind of a pain. 1, 2, 3. Now I've got to finish off this rectangle, so that then gives me, how do I finish it off? Now here's the key component, here's the key thing. When you build these rectangles, I do want the x's to be on the bottom left corner. It doesn't really mathematically matter, it still gives you the right answer if you put it in different parts. It's just easier to have a structure. So putting the x's on the bottom right corner is always the ideal thing to do. Or bottom left corner, my bad. But then the other key thing is, you do need to make sure that your lines, you could draw lines all the way across your work, okay? And if you do this, if you do this, it kind of shows you what you need. So going like that, you can say, oh, well, that means I gotta follow on my x's here, and here's another x, and here's another x, and then 3 tiles. Now, of course, I do this one and it looks so easy, so you're like, oh, this is a piece of cake, bring it, Mr. Ramirez. Yeah, they will get a lot more challenging, trust me, okay? So then I need to finish off my answer, which said to write the area as a product and the area as a sum. So 2x squared plus 1, 2, 3, 4, 5, 6, 7 plus 7x plus 3. And there's my answer to this problem. So that is what we're going to be working on tomorrow in class. I think it's a fun challenge. You will all be using your Chromebooks and using your online algebra tiles to do this. So please make sure your Chromebooks are ready tomorrow for class. Make sure they're all charged. Make sure everything's good to go. And that's it for today. So I'll talk to you later.